Hi all, this is Dr. Shanthi, Professor, EC Department, RMK College of Engineering and Technology. In this presentation, we are going to see the various bacterial attacks in body area networks. Now, we know what happens if there are interferences. What happens is there are threat to the body sensor networks. What happens is the body sensor network will fail. What are the threats to the body sensor networks? You have two types of analogy. One is bacterial analogy and the other one is virus analogy. Now, compromised nodes, we give it a bacteria analogy. These are like bacteria attacking network integrity by releasing harmful actions. The next one is malicious programs. It is virus analogy. Here what happens is data packets or malicious programs infiltrate and infect sensor nodes, damaging the sensor network. Now we are going to see 13 possible bacterial attacks. Bacterial attacks, there are 13 bacterial attacks. First 5 we have seen in the previous presentation. That is jamming, collision, exhaustion and interrogation, selective forwarding and sinkhole attacks. How compromised nodes disrupt the body sensor network. Now let us proceed on with the 6th bacterial attack, which we are going to call it as Sybil attack. To form a network and create routing tables, every sensor node has to have a unique identity. In a Sybil attack, a malicious node creates fake identities in order that it can appear in multiple places at the same time. Now look at the diagram. The attacker, that is the malicious node, will appear as sensor node B to sensor node A. To sensor B, it acts as sensor C, and to sensor C it acts as sensor A. So what happens is it creates fake identities. So that is what is going to be called as Sybil attack. It will be therefore be more likely to be selected as a part of a hop for forwarding messages, thus opening the gate for selective forwarding attacks. In the case of selecting forwarding attacks, only part of the messages will be forwarded to the destination. Next is going to be wormhole attack. In the case of wormhole attack, attackers cooperate to simulate a low latency communication link. Right? Now what happens is, now we take the shortest path from one source to the destination. Now the attackers will play a role such that from the source to the destination, the attackers will come in the middle and create as though the path is the destination. It acts as a destination or it creates a low latency path. Message received by one of the attackers will be replayed by the other attacker so that the message appears to be forwarded from a nearby hop. As such, the neighboring sensor nodes will favor the attacker for routing similar to a sinkhole. In addition, the network will be severely disrupted when the wormhole is removed. See here, this is the wormhole. That is the attacker here. Actually, sensor node here, actually the attacker will say that it is the nearest node in the routing path to sensor node D, but actually it's not, right? So these two are wormholes. Now if these two are removed, what happens? The entire network will crash. Next one is going to be called as acknowledgement spoofing. Right. Now what happens here is, if that is to ensure the integrity of the link and improve the reliability of data transmission, acknowledgement messages are often required from the receiver. In an spoofing attack, what happens is the malicious node spoofs acknowledgement messages, aiming to trick the sender in believing that a weak link is strong or a dead node is alive. For example, the attacker will send, rather than the receiver sending acknowledgement messages, the attacker will send acknowledgement messages. As typical routing protocol selects hops based on the reliability of the link, the attacker can effectively launch a selective forwarding attack by encouraging the target node to transmit packets through those weak links. Right? So it can act as a hop, uh, right, and resulting in selective forwarding attack. The next one is going to be called as hello flood attacks. Right now, if to introduce a new sensor and update the routing table dynamically, many wireless network protocols require the new sensor to broadcast an announcement message, the hello message, to notify its neighbors of its request to join the network. In a hollow flood attack, adversary broadcasts powerful hello messages to many nodes in the network so that every node thinks that the attacker is within the short radio range. Right? Actually, uh, to the other nodes, it appears that a new sensor node is coming into the network. But it is actually the attacker or the malicious node joining the network using hello flood attack. This will cause a large number of nodes to attempt to use the attacker as a hop to route messages, thus confusing the entire routing system. Right? So this is a hello flood attack. The next one is going to be buffer overflow. As limited storage is available in each sensor node, flooding a sensor node with messages will lead to buffer overflow and subsequently crashing the node, right? So what happens here is you will have a sensor node A and the attacker will be sending on the messages so that you will have, that is, it will crash the node. Next one is network scanning. Through scanning the network and obtaining the network topology, the attacker can locate a particular sensor node or even the individual wearing the sensors. Right? So this attack is going to be called as network scanning. The next attack is going to be called as traffic analysis. As the network traffic pattern is often used to detect and defend attacks on the network, through observing the traffic patterns, the attacker can potentially compromise the security defense of the system. Right? By studying the traffic pattern, a malicious node can attack the system, right, or affect the body area network. The next one is false alarms. Being a pervasive monitoring system, BSNs are required to accurately capture abnormal events and transmit alarm messages to the system. But what happens is, by generating many false alarm messages, an attacker can effectively undermine the system's ability to detect genuine abnormal events. So, by sending many false alarms, the original abnormal events will go unnoticed. Thank you.